Good morning, children. So welcome back to the online session of a mathematics class. So as we know that we are discussing about circles lesson. So in that we are discussing about the exercise 4.2. So in the 4.2, in the last video I had discussed about the third and fourth question, which will be the finding a missing angle by considering a quadrilateral. There will be three known angles, so there will be four unknown angle. That unknown angle we need to find out by using the use of angle between the radius and then tangent will be 90 degree. Using that concept, the length of the tangent, not length of the tangent, it is theorem 1. The tangent at any point to a circle is perpendicular to the radius to the point of contact, which is very important when we are having a circle. Okay, then circle is center O. Then we have a tangent from the external point, with the point of contact P. Then if we are joining O and P, then this angle must be 90 degree. Okay, so that means radius at the point of contact and tangent at any point of the circle will be perpendicular to each other. So that is theorem 1. If I had one more tangent, then these two tangents are equal. PR is equal to length of these two tangents are equal. That means length from P to R and length from R to Q will be equal. That means length of tangents are drawn from external points are equal. This is theorem 1. And second one is this theorem 2. So those two theorems are very important as we have discussed in the earlier videos. Okay. So based on this concept and then based on the concept of congruency, we need to find out this angle. Okay, this angle. So I have explained in the third question how to find out that. First we need to find out this total angle. We will be giving this angle 80 degree, and we know that this is 90 degree, and we know that this is 90 degree. Then we should find out this, considering this will be the quadrilateral, right? So we need to find out this complete angle. Then we should find out this by using the concept of congruency. We need to prove this OPR and then OQR will be congruent. Then we need to prove that these two angles are equal. Then what will be the total angle? That half of the angle will become angle POR. Okay, that we need to find out that. Okay, so that is we have discussed in the question number 3, and question number 4 will be finding two lines. That means if I have a tangent and then it's on the diameter. Okay, so here we will the diameter. Then this is considered as PQ is the one tangent, RS is another tangent. So we need to prove that these two tangents are parallel. The tangents drawn at the ends of the diameter are parallel to each other. That we need to prove that. Okay. So by proving that alternating interior angles are equal. By proving that alternating interior angles are equal, we have to prove that tangents are parallel to each other. So these two things we are learning in the last session. So in this session we will go for the question. So which is prove that the perpendicular at the point of contact to the tangent to a circle passes through the center. Prove that perpendicular at the point of contact to the tangent to a circle passes through the center. Okay. Let me write the diagram from this. I am having a circle with center O. Okay. With center O. We need to prove that perpendicular at the point of contact to the tangent of the circle. So therefore there will be a tangent. So there will be a tangent in the tangent. Okay. So point of contact. Let me take this as P. Okay. This is O. Okay, so let me make AB as a tangent. AB is a tangent. Okay, so what we need to prove that? Prove that the perpendicular at the point of contact to the tangent to a circle passes through the center. center. So this is the tangent. This is the tangent perpendicular to this tangent. Perpendicular to this tangent should pass us through the center. That we need to prove. The meaning of this theorem will be, we will be having a center and we will be having a tangent at the point P. We need to prove that if I write the perpendicular to the tangent, that will pass us through the center. That will pass us through the center. So that we need to prove this in this question. Okay. So this is a tangent. So this is a tangent in the sense perpendicular in the sense it must be 90 degrees. So whatever this perpendicular line will be there, that must pass us through the center. If I write perpendicular to this must be passes through center. It should not be like it is passes through apart from center, nearby center. It has to pass us through center. So that is the meaning of this theorem. So how to prove that? Let's see. Okay. So then first we will define that what we have taken. We have written the circle, right? Let us consider a circle with center O. Let us consider a circle with center O. Let us consider a circle with center O. Okay. Let AB be the tangent. Let AB be the tangent. AB be the tangent touches the circle at P. So let us consider a circle with center O. Let AB be tangent touches the circle at P. So what we need to prove that? We have to prove that the line perpendicular to AB. So AB is the tangent, right? The line perpendicular to AB passes through the center. Passes through the center O. So passes through the center O. We have to prove this. We have to prove that the line perpendicular to AB passes through the center O. Now we will be proving this theorem by the contradiction method. We have learned that what do you mean by contradiction method in the real numbers lesson. We have proved the theorems, that is root 2 is irrational, root 3 is irrational. These type of problems we have proved by using the contradiction method only, right? So what do you mean by contradiction method? We will be assuming in a reverse manner. Suppose if it is passes through center, then we will be assuming that it is not passes through center. We will be assuming in a reverse manner. Then we will be concluded with some contradiction. We will be concluded with some contradiction. That means some wrong statement. So that concludes that our assumption is wrong. Initially, whatever our assumption is taken, that is wrong. So it has to pass through the center O. Suppose the question is here, the line perpendicular to the tangent should pass through center O. So this we need to prove by contradiction method. So what we need to assume that? Assume that the line perpendicular to the tangent AB does not pass through O. The center O. That means it is passes through some other point on the circle. So we will be defining like that. So in the end, we will be come with some wrong statements. So that will conclude that our assumption is wrong. So that is the contradiction method. So let us prove this by contradiction method. So we shall prove this. We shall prove this by. We shall prove this by contradiction method. circle with center O. A will be the tangent which touches the circle at point P. So that is what we have done here for the diagram. So this line will be what we need to prove that. We have to prove that the line perpendicular to AB passes through the center O. This will be there in the question itself. We need to prove that the line perpendicular to the point of contact to the tangent to the circle passes through the center, which is there in the question itself. This is the line. Okay. So we from which method we are going to prove this theorem? That will start. Actual proof will be starting from here only. So we shall prove this by contradiction method. So we will prove this by contradiction method. So let us assume that the line perpendicular to tangent AB does not pass through so we have taken a reverse manner. Does not pass through the center O. Does not pass through the center O. We have taken a reverse manner. We need to prove that it has passed through center O. Since it is a contradiction method, we will be taking the reverse process. Let us assume that the line perpendicular to tangent AB does not pass through the center O. So it is not passes through the center O in the sense it actually passes through some other point on the circle. You may say that it has passes through O dash. It is not passes through O, it is passes through O dash. Right? So perpendicular it is not passes through center O in the sense it is passes through some other point on the circle. Okay? So we'll write that let it passes through another point. Let it passes through. Let it passes through another point O dash. Let it passes through another point O dash. We have taken as O dash. Okay, O dash. Otherwise, we will take one more point like any other point. We will take it as R. Let it passes through point R. Okay. So let us assume that it is not passes through. Let it passes through another point R, which is inside the circle. Now join OP and RP. So we have already joined OP. We will join RP also. We will join these. Okay. OP and RP. Okay. So we'll join OP and RP. Symbol of perpendicular as perpendicular to AB, passes through R. So we know that this is AB. So I will be having a perpendicular. Perpendicular means it is 90 degree. And we have assumed that this passes through point R. That means what is the angle? What is the angle? What is the angle between R, PB, which is 90 degree? What is the angle between R, PB? It is 90 degree because it has passes through R. We'll write that. Okay. So as perpendicular to AB passes through R. So therefore angle RPB must be 90 degree. So we have defined that. Perpendicular to AB passes through the point R. So therefore, since it is a perpendicular, the angle between that perpendicular and the tangent must be 90 degree. Okay. So that we have written. Okay. So We know that OP is the radius and AB is the tangent. OP is the radius and AB is the tangent. Then angle between the radius and the tangent must be 90 degree according to the theorem 1. So tangent at any point to the circle and then radius to the point of contact, both must be perpendicular to each other, right? So what it means that angle, this angle is also 90 degree. That means angle OPB must be 90 degree. So since OP is radius and AB is tangent, AB is tangent. Since OP is radius and AB is tangent, angle OPB must be 90 degree. OPB must be 90 degree. So this equation 1 will be from our assumption. What is our assumption? We have assumed that perpendicular to AB passes through R. It is not passes through a center O. It is passes through some other point on the circle, which is R. Right? That is from our assumption by contradiction method. This statement. Equation 1. Equation 2 is from the theorem 1, that is tangent and radius are perpendicular to each other. Therefore, OP is equal to 90 degree. OP is the radius and then AB is the tangent. Angle must be 90 degree. Clear? So now we will compare equation 1 and 2 because on the RHS we have both 90 degree and 90 degree. We will compare both the equations. RHS we are having 90 degree and 90 degree. We will compare equation. Comparing 1 and 2, comparing equation 1 and 2, we get, since RHS are equal, LHS must be equal. That means RPB is equal to angle OPB. RPB is equal to angle OPB. Call this as equation 3. RPB is equal to OPB. So, and also you can observe the figure. Whatever the angle will be there from RPB is less than OPB. From the figure, it is clearly seen that angle between RPB then OPB, you can see that this angle will be less than this angle. Correct? From the figure, it is clearly visible, right? So we'll write that. From the figure, it can be observed that angle RPB is less than angle OPB. Equation 4. So you can observe that RPB is equal to OPB. RPB less than OPB. Both are not possible, right? At a time, both are not possible. If you take two numbers, so if 2 is equal to 2, then you can't say that 2 is less than 2. Either any one of the equation must be true. If this is true, then how can this will be true? If I take 2 is less than 3, then you can't able to write 2 is equal to 3. If this is true, then this is false. Correct? If this is true, then this is false. If 2 is less than 3, then 2 is not equal to 3. Correct? This is false. If this is true, then this is false. If this is true, then this is false. Right? You can observe that RPB is equal to OPB, RPB less than OPB. Okay, because both will be true. Either this will be true or this will be true. But we will be concluding that both are true. We are getting both equations are true. This is a wrong assumption. This will conclude that a wrong assumption. So which is wrong assumption? Therefore, if this is true, then this is not possible. Angle RPB is equal to OPB is not possible. It is not possible. So since it is true from the figure is less than RPB is less than angle RPB is less than OPB, then this is not possible, right? So which is equal to is not possible. This is possible only when, okay, so it is only possible when the line it is possible only when the point R coincides with O. With the point O coincides with O, then only it is possible. Which is possible? And both the angles are equal. That is possible. Coincides with O. Therefore, our assumption is wrong. What is our assumption? From the contradiction method, we have assumed that perpendicular to the line perpendicular to the tangent AB does not passes through the center. That is our assumption from the contradiction method, right? We have arrived with the wrong statement. Therefore, our assumption is wrong. What is our assumption? The line perpendicular to the tangent does not pass through the center. That is our assumption, right? That is wrong. So therefore, the line perpendicular to the tangent must passes through the center. That is the correct statement. Okay. So therefore, the line perpendicular to the tangent AB passes through the center O. Okay, that is correct. But our assumption is wrong. What is our assumption? It does not pass through the center O, it does passes through the another point R, which is wrong. Why it is wrong? Because we have arrived at some wrong statement. Angle RPB is equal to OPB, and then RPB less than OPB. Both will be, you will be getting both the equations, which is not correct, right? Either one of the equation must be true, right? So therefore, which is wrong. So this our assumption is wrong. Therefore, it has to pass through the center O. Okay. So this will complete the proof. Okay. This will complete the proof. Okay. So we'll go for the next question. So sixth question, which is very easy. The length of tangent I can give you this question as well because it's a repeated question. Length of tangent from a point A at a distance 5 cm from the center of a circle is 4 cm. Find the radius of the circle. Length of a tangent they are given. So they are given the center. They are given the center. They are given the circle with center. Okay. So they are given the length of a tangent, right? Length of a tangent from a point A at distance 5 cm from the center of the circle is 4 cm. So we will be having a tangent, okay, which is from here. Let me take it as a B. Okay. So length of tangent is 5 cm from the question. The same tangent from the center, it is 4 cm. From the center it is, from the center it is 5 cm. From the length of the tangent from a point A at distance 5 cm from the center of the circle. So from the center of the circle it is 5 cm. Length of the tangent is 4 cm. Center of a circle is 4 cm. Find the radius of the circle. So we should find out the radius of the circle. So this we need to find out from this. They have given the length of tangent. They have given the distance between center and the external point. So it is very easy to find out the radius. So by applying the Pythagoras theorem. Okay. So do this because this will be the homework for this question. This is this question. So this is homework for you. This you need to complete this. So in the next class I will go for the 7th question. Okay. So any doubts in today's class? The theorem, the line perpendicular to the tangent AB must pass through the center O. So any doubts on the theorem, you just get back to me to my WhatsApp number, or otherwise you can call me. Okay. So thank you. We will meet in the next video.